So one of the areas that we start out with then when we talk about this situation, if we've got the integral from a to b of f of x dx, we say, all right, if f of x is a continuous function on a closed interval from a to b, and capital F it's its antiderivative, just what we talked about at the beginning of this quick start guide, then we see that the antiderivative evaluated at b minus the antiderivative evaluated at a will give us the value under that curve. And we can actually verify this for ourselves by going back to an earlier step. We said, well, let's consider the function 2x plus 1. Would that work here? Well, let's try it out. We know that the antiderivative of the function 2x plus 1 from our earlier videos is going to be 2 times 1/2 x squared plus 1x plus c, which is to say x squared plus x plus a constant. So if we evaluate the antiderivative, this is f of x, our antiderivative at 3, we get 3 squared plus 3 plus c, which is to say 9 plus 3, 12 plus c. And if we take the antiderivative and evaluate that at 1, we get 1 squared plus 1 plus c, which is to say 2 plus c. And so if we take f of 3 minus f of 1 as per our first fundamental theorem, that means we're taking 12 plus c, subtracting 2 plus c, and we just get 10, which is exactly what we said should happen. So we are in the clear. This is exactly what it says to do. Notice, by the way, that the constant of integration just goes away, so we never really deal with it when we're dealing with the definite integral. So let's try this a couple of times. If I wanted to evaluate the definite integral from 0 to 2 of 4 minus x squared, I'm going to find my antiderivative of 4 minus x squared. The antiderivative in this case is going to be 4 times x minus 1/3 times x cubed, which is the antiderivative of x squared, remember? And I'm going to evaluate this from 0 to 2. This is a notation right here, which means take 4 times 2 minus 1/3 of 2 squared, and subtract from that 4 times 0 minus 1/3 of 0 cubed, and work out the numbers, which is 8 minus 8/3, all minus, well, 4 times 0 minus 1/3 of 0 cubed is 0. So if we take 8 minus 8/3, that is to say 24 minus 8, or 16/3, we're saying that the area under the curve right here will be 16/3. Okay, not bad. Let's talk about this one. If we take the integral of sine of x on the interval from 0 to pi, that's that little area here in green, what do we get? Well, let's go with our integral. With the antiderivative of sine of x, we said is negative cosine of x, and we're going to evaluate this from 0 to pi. And this notation means take the negative of the cosine of pi and subtract from it the negative of the cosine of 0. So doing that, well, cosine of pi is -1. So we're taking the negative of -1, and we're going to subtract from it the negative, or well, add, I guess we should say, the cosine of 0, which is 1. Well, it turns out that that total area is 2. So that's what we do.